We'll now begin section 5.5, Exponential and Logarithmic Equations. This is the last section in chapter 5, and so many of the concepts that we have learned up to this point come together in this section. We're going to first do a quick review of the concepts that we have learned in the first 4 sections of this chapter. So first we want to remember that the equations x is equal to a to the y and y is equal to log base a of x are equivalent. Remember that this rule helps you switch between logarithmic and exponential form. Number 2 says the inverse of the function f of x is equal to a to the x is f inverse of x is equal to log base a of x and vice versa. So this statement gives you the ordering to go from a function to its inverse. The third, fourth, and fifth statements are the properties that we learned in the last couple of sections. We have the property that says that if we're taking the log of a product, that we can break that product up into a sum of logs. We have a property that says if we're taking the log of a fraction, that we can break that fraction up into the difference of 2 logs. And we have a property that says that if we have an exponent, that we can move that exponent to the front of the log. So we want to keep these 5 concepts in mind as we start this section and begin to look at solving logarithmic and exponential equations. So our first example asks us to solve the equation 3 raised to the 2 minus 5x is equal to 11. Now, the one approach that we can use for this problem is that we can take the log of both sides of the expression. Now, you have an option here. You can take the regular common log of both sides, or you can take the natural log of both sides. It does not make any difference which one you use, and we'll do an example for each. On this one, I'm going to put the natural log in front of each side of the equation. Now, once that's done, we're going to employ one of our properties that says that we can take an exponent and pull it to the front of the log. So that 2 minus 5x, I'm going to bring down. Now, when I bring it down, I'm going to put it in a set of parentheses to remind myself that that whole quantity is multiplied by the natural log of 3. Then our goal becomes to solve for x. And so you want to think about what do you need to do to get x by itself. And so one thing we can do is we can divide both sides by this natural log of 3. That would cause it to cancel on the left, so that gives me 2 minus 5x is equal to the natural log of 11 divided by the natural log of 3. Continuing to solve for x, we're going to subtract 2 from both sides. Which will give us, I'm going to come up here, that's going to give me negative 5x. Is equal to natural log of 11 divided by the natural log of 3 minus 2. And then the last step is going to divide both sides by that negative 5. Alright, and that's going to give us x is equal to, now on the right hand side that might be a little bit confusing, so we want to be careful with that. You can certainly use your calculator at any point if you so desire, but I'm going to break this up. I'm going to write natural log of 11 over the natural log of 3, and I'm going to divide that by negative 5. And then I'm going to put the minus 2 over the negative 5, because we know that that negative 5 is going to really apply to both of those terms. Okay, so when I look at this one on the left, the first one, we know that we really can't divide, but instead we multiply by the reciprocal. So I'm going to come off to the side somewhere and just kind of show you, make sure you understand how this is working. So we have this natural log of 11 over the natural log of 3, and we're dividing by negative 5, which is really the same thing as multiplying by negative 1 over 5. All right, so that part becomes negative natural log of 11 over 5, I'm just going to put it in the front, times the natural log of 3. And then this negative 2 over negative 5 becomes plus 2 over 5. Okay, and so that's going to be the exact value for our answer. You could also put it in your calculator, and if you type that in your calculator and evaluate, you would get negative 0.037. And again, if you have any difficulty typing that in your calculator, please email me and let me know. Okay, so again, in a problem like that, you can take the log or the natural log of both sides and then use your properties to solve. So that was our approach on that equation. All right, example 2, we have 5 raised to the 3x minus 1 is equal to 2 raised to the x plus 3. Now, we're going to approach this in the same way. We could take the natural log of both sides, or we could take the regular common log of both sides. I'm going to go ahead and do the common log of both sides. So we'll just write the word log in front of both sides of the expression. And then we'll do the same thing that we did in the last example. We'll use our property to pull those exponents to the front. When we pull them down, we want to be sure to put them in parentheses. Okay, now again, our goal is to solve for x. So since we have a parenthesis on both sides, we may want to go ahead and distribute. So we could multiply this log 5 times both of those terms, and we can multiply the log 2 by both of those terms. So that's going to give me 3x log 5 minus 1 times log 5 is equal to x log 2 plus 3 log 2. Now, since our goal is to solve for x, we want to get everything that has an x on one side and everything that doesn't have an x on the other side. So we sort of want to rearrange these terms a little bit. I'm going to put my x's on the left, so I am going to first add this log 5 to both sides. So that's going to give me 3x log 5 only on the left. And then x log 2 plus 3 log 2 plus log 5. All right, remember we're aiming for all the x's to be on the left and all the things that don't have an x to be on the right. So my next step is to subtract this x log 2. All right, so that's going to give me 3x log 5 minus x log 2. None of those are like terms, so I really can't combine them. And then on the right, 3 log 2 plus log 5. All right, so now once that's done, we're going to take the two terms on the left and we're going to factor out the x. All right, so I'm going to go ahead and let's see, let me go to my next slide just so I have some room. Kind of write down where we're at. 3x log 5 minus x log 2. 3x log 5 minus x log 2, okay, is equal to 3 log 2 minus or plus log 5. Okay. All right, so that's where we left off. We're going to now factor an x out of the two terms on the left. So we're going to pull that to the front. When you pull an x out of the first term, you're going to be left with 3 log 5. Pull an x out of the second term, you're going to be left with log 2. And we're going to leave the right-hand side as it is. And then we're going to divide. So we'll divide both sides by everything over here that is not an x. So divide by 3 log 5 minus log 2. 3 log 5 minus log 2. Okay, so exact answer would be 3 log 2 plus log 5 divided by 3 log 5 minus log 2. And if you decide to put that in your calculator and give an approximate answer, you're going to have 0.892. All right, so that finishes up that example. All right, our third example asks us to solve the equation log base 7 of 3x minus 2 is equal to 2. Okay, and so this is a log equation. We can begin by writing the equation in exponential form. Sometimes you will find that an equation that is difficult to solve in log form might be easy to solve in exponential form, so it's worth checking. If I put it in exponential form, I'm going to start with that base of 7, go to the other side and get my exponent of 2, and then I'm going to set it equal to what's left. So if you look at that, 7 squared is 49, and so it transfers itself very nicely into just a regular linear equation. And so we can definitely solve that thing for x pretty easily. We can add 2 to both sides. So that's going to give me 51 is equal to 3x. And then divide both sides by 3, and we end up with x is equal to 17. All right, and then our last example, solve the log equation. Log base 5 of x is equal to log base 5 of 2x plus 3 minus log base 5 of 2x minus 3. Okay, so if we're thinking about what we can do here, we know that we have a property that deals with the subtraction of logs. So hopefully that kind of jumps out at you. That's one option that we have there, is to take that right-hand side of the equation and write it as a fraction. So I'm going to write it log base 5 of 2x plus 3 divided by 2x minus 3. Okay, now here's the thing with this. If you look at this and you think about these two things being equal, they both need to have the word log, which they do. Both sides need to have a base 5, which they do. And then this part needs to equal that part. And so what we're basically going to do is we're going to sort of set that equal and figure out, how does that happen? How does x equal 2x plus 3 over 2x minus 3? And so let's cross multiply this thing, get rid of our fraction. So I'm going to multiply x times 2x minus 3. And I'm going to multiply 2x plus 3 times that 1, so it would just be 2x plus 3. Okay, so now it's not really a log equation anymore. We can just use our regular techniques for solving for x. So we're going to distribute the x first. So that's going to give me 2x squared minus 3x is equal to 2x plus 3. So I'm seeing that it's quadratic with that squared. So I'm thinking I would like to factor it if possible. So I know I need to move everything to one side. So I'm going to subtract that 2x off. Give me 2x squared minus 5x is equal to 3. And then I'm going to subtract the 3 off. And so that's going to give me 2x squared minus 5x minus 3 is equal to 0. And I'm going to see if it'll factor. So first times first, to make 2x squared, I know that's going to have to be a 2x and an x. And for the 3, it's going to have to be a 3 and a 1. So I may need to play with that just a little bit, but I think it's going to need to go 3 and 1 there. I'm checking as I go. So my FOIL method, the outside would be 6. And the inside would be 1. So I need to subtract that to make the 5. I need the 6 to be negative. So that'll make that negative. And the other one would need to be positive. And so as we set each of those equal to 0 and solve, we'll come up with x is equal to -1/2. And we'll come up with x is equal to 3. Now, it is important here when you're solving these logarithmic equations that you check your answers, that you at least glance at these answers. Remember that you cannot take the log of a negative number. That is not defined. So this -1/2 is going to be a problem, because when you go and you plug these values in and you put a -1/2 right here, this can't be done. Okay, so that one is out automatically. Let's look at the 3 and make sure that that one's going to be okay. And the actuality is I don't really have to solve it all the way. I just have to be sure that I am not taking the log of something that's negative. So that's going to be fine. Log base 5 of 3 is going to be fine. And then we were going to plug a 3 in right here and plug a 3 in right here. And I think both of those are going to be okay, because that would be 6 plus 3, that'd be 9 on the top, and 6 minus 3 would be 3 on the bottom. So 9 over 3, we would have a positive number. So as long as they're positive, you were okay with your solution. So our only answer there would be x is equal to 3.